This is the new universal HD 1080p compression connector. What's good about this connector is not only the electricals, but it works on every conceivable coax cable that you will use. RG59, there's my strip tool, 1/4 inch of braid, and then I always cut the center conductor off at 1/4 inch, but at a 45-degree angle. Then I take the connector, I pull out the little sleeve that holds the contact, and here's what I want to bring out, is there is a little wafer inside this contact. Now in our world, that is important, because with high resolution, you want to make sure that you have the tightest mechanical fit between the OD of the center conductor and the ID of the contact. That is where your signal is. Slide it on, fold the braid back, push the connector on. You want to make sure that the contact comes all the way out to the mating face. I put the connector inside the die head, and all I want to use it as is a pair of pliers and squeeze the thermoplastic into the back of the connector. And there you are. And that will not come off, ever. Now, just to make sure that you're aware that this connector will work on every cable, I'm going to terminate the RG6 quad shield right here in front of you. Now to do that, I take my strip tool, I adjust the die insert to RG6. I'm going to cut this off nice and clean. Perfect. Cut the center conductor off at 1/4 inch on an angle. Same connector, right out of the same box. Take the contact out of the wafer. And again, with that little washer, now it'll fit the gauge wire of RG6 quad shield. Slide it on. Put the braid wires back. Connector goes on, contactor's all the way out. Put it in the tool, squeeze it down. So that takes care of the coax side of our CCTV business. But I also now have a redesigned pass-through RG45 connector where the wires come right straight through. And this is where the major problem always comes up, is the pinout. It's either a 568A or a 568B. And if you can't see those colors inside that connector, it's going to mess up from time to time. This one slides all the way through. You then take the connector. Put it into the tool, and I will cut and crimp at the same time. And there you are. What I have here, I've got them in 4, 8, and 16 channel. This is a video power hub, but what is very, very important is that there is a 36-volt power supply in it. So what I'm doing is running 500 feet at 36 volts over Cat5. This is at the head end, and then at the camera end, I have a voltage reducing adapter that brings it down to 12 volts so that I can use this camera, which is a HD TVI camera. You can go 750 feet on Cat5, video and power. In the old days, it was 100 feet. Today, because we learned from the old days, it's 750 feet. Here is a picture of an IP camera being run over 500 feet of RG59 plenum cable. Video and power, if you want to call it Ethernet and power, and this is extremely cost effective. Now you saw the results of my video and power over RG59 plenum for the HD 1080p TVI CVI installation. Here's how it works. Here's my converter at the DVR, and there's the RG59 cable, and there we are again. That is a 36-volt power supply. So what I'm doing is I'm adding power to this converter. There's my video feed, there's my power feed, and I'm running video and power over this RG59 cable all the way out to this spool of 500 foot of cable. And there's the other end. I have a video and power converter at this end. I can go 1,300 feet with that. Now I want to show you the hookup that we had with the IP over coax cable. There's 500 feet of RG59 plenum. Once again, and also you'll notice that I've got the compression connector on here constantly. There's my IP camera. I'm coming out of the IP camera with this transmitter. There's my Cat5 feed. There's my coax feed down to the cable. Coming back into this PoE switch, or what I call it a POC converter. It is a 16-channel converter. And I'm coming out of here now with the Cat5 into the NVR. And from here on out, it's the same as any other IP installation. I can convert 16 coax cables that are in a building to video and power over that coax for IP. So if you've got 16 coax cables in a building, it's going to cost you $1,000 a piece to replace each of the cables. That's $16,000. What you now can do is just take the coax cables that's there, and for $1,600, you can convert them all over to IP. So what I'm demonstrating here is you can use any cable that's in your install. You're going to it'll be an easier install, a more cost-effective install. You'll make more profit, and that goes right to your bottom line. I hope you'll try them. I hope you'll use them, and give me a call at any time. www.gemelect.com. And I thank you all very much for listening.